Okay, so today we're going to be talking about acid-base reactions. Now, acids produce the hydronium, the H plus ions, whereas bases produce the hydroxide, the OH minus ions. That's kind of what we reviewed the past couple days. Now, in a reaction involving acids and or bases, there is always a transfer of these ions. Particularly, there's always a transfer of your hydronium ions, your H1 plus ions. Now, an acid donates the hydronium ions, which is called a proton donor. And bases accepts the hydronium ion, which becomes a proton acceptor. So it's going to be a transfer of the H plus ion. One form of an acid-base reaction is when an acid or a base reacts with water to form a conjugate acid and a conjugate base. Now, conjugate acid is what forms after the base has accepted the hydrogen ion. So a base accepts the hydrogen to become a conjugate acid. And the conjugate base is what remains after the acid donates the hydronium ion, meaning once the acid has given away the hydrogen, it becomes a conjugate base in a reaction. Now, just to note, water can act as an acid or a base because it contains both H plus and OH minus. So it contains both parts that an acid and base contains. When water acts as a base, as an acid, so meaning that the water is going to is the component that donates the hydronium ion, so it becomes a proton donor, it will become OH minus, and that is the conjugate base for that reaction. Now, when a water acts as a base, meaning that's the part of the reaction that will be accepting that H plus ion from the acid, it'll become H3O plus, which is your conjugate acid in that reaction. Okay, so let's go ahead and do some practice problems of completing the following acid-base reaction and identifying the acid, base, conjugate acid, and conjugate base in the reaction. So A, we have NH4 1 plus H2O yields. We have to find the two products first. The very first step I like to do is look at our reactants. Now, our reactants is always either going to be an acid or a base, okay? Conjugate acids and conjugate bases are your products. So we have to figure out, is this going to be an acid base or is this going to be an acid base? Now remember, acids is where you have an H1 plus, or it's where it can give a hydrogen, okay? As we said, yes, water can give hydrogen, but hey, we have a +1 charge. And remember, H has a +1 charge. So this is where our hydrogen is going to come from. So that means NH4 1 plus in our case is going to be our acid. And then that means, since this is going to be our acid, our water is going to act like our base for this reaction. So with that being said, one of the hydrogens is going to go to our waters. So after this hydrogen is gone, we left one hydrogen. That means we have 3 hydrogens left over. So our first product is going to be NH3, sorry, since we're losing that hydrogen. And we no longer have a plus charge because we're getting rid of that hydrogen 1 plus, so that goes away. So that's our first product. And then now our water has accepted a hydrogen, so it gained a hydrogen. So we have H3O. But remember, the hydrogen has a +1 charge. There is no charge for water, so now this H3O has a 1 plus charge. So those are going to be our two products for this reaction. So now we have to figure out, is this going to be a conjugate acid or a base, or is this going to be a conjugate acid or a base? Now, remember, conjugate acids is what has accepted the hydrogen, okay? Well, our water has accepted the hydrogen to become this. That means this is going to be our conjugate acid now. And then remember, our conjugate base is what gave that hydrogen away. Well, our NH4 1 plus gave it away to become NH3, so this is going to be our conjugate base. Okay. So this is what I'm going to expect you for the homework and for the test to see all of this work, because the homework will be a file upload. So let's go ahead and move on to B. We have HF plus H2O yields to two products. So we got to figure out the two products first. But very first step is to figure out which reactant's an acid and which one's is a base. Remember, the acid is what wants to give away the hydrogen, and the base is what wants to accept it. Now, again, remember, water can be both, so we'll have to look at the other one that's not water, which is HF. Now, HF has a hydrogen. That means it has a hydrogen to give, so it's going to be an acid. Therefore, in this case now, water is going to be a base. Now remember, acids wants to give away our hydrogen, so that means that the HF is going to give away that hydrogen to water. So with that being said, HF gave away its hydrogen, so all that's left is F. But it had a 0 charge, and it got rid of a +1 charge. So that means now this has a -1 charge. So we're getting rid of that positive, okay? Going back. And then now our H2O accepted a hydrogen, so now we have H3O. It had no charge to begin with, so that means it gained a +1 charge, so this compound is going to have a +1 charge. So now we have to figure out what is the conjugate acid, what is the conjugate base. Remember, the base is the one that got rid of the hydrogen, and then the acid is what accepted the hydrogen. So looking at our HF became F1 minus because it got rid of the hydrogen. That means this is now a conjugate base. Our water accepted a hydrogen to form this, so now because the water accepted it, it became a conjugate acid. So that is what the answer would be for this problem. So let's go ahead and move on to C. Now we have two reactants. We have OH1 minus plus HCN. So we got to figure out which one's an acid, which one's a base. Well, this one has no hydrogens it can give. Note, if it's going to be a hydrogen you're giving away, it's either going to be NH4 1+, a water, or the hydrogen is going to be in the very first one. So since there's really no hydrogen to give away, this is going to be our base. And I know you're going to think that there's a hydrogen, it's going to give it away, but this is OH1 minus, so it's not going to give that away. And also, if you look at this one, we have a hydrogen, the very first one, so this is going to be our acid. That means that this hydrogen is going to be donated to the acceptor, to the base. So now that OH1 minus has accepted a hydrogen, we're going to have 2. So what happens now, we have 1 oxygen and 2 hydrogens, so this is going to become water. And we had a -1 charge, and we're just adding a positive charge, so that means we're going to have a neutral charge now. That charge is going to go away. And now we have a compound that got rid of a hydrogen, so we just have SN, a CN. There we go. Now we just have a CN, and we had a 0 charge, but we're getting rid of that positive charge, so that means now this has a -1 charge. Okay. Now we got to figure out which one of these is a conjugate acid, a conjugate base. This OH1 minus accepted our hydrogen, so that means this now has a hydrogen to give away now, so it's going to be a conjugate acid. And this one gave away a hydrogen to form this, so it has no more hydrogens to give, so it's going to become a conjugate base. And that would be your answer for this one. So let's go ahead and do D. Now, very first step is to figure out which one of these is going to be our acid or our base. Well, this has hydrogen in front of it, so this is going to be automatically going to be our acid. And then that means this one's going to be our base. So that means the hydrogen and the HCl is going to be donated to our NH3. So now that this hydrogen is going to go away, the only thing we have left over is our Cl. We had no charge, we just lost a +1 charge, so now we have a -1 charge. And then NH3 has accepted a hydrogen, so now we have NH4. It had no charge, so now we adding a +1 charge from the hydrogen, so that means now we have a +1 charge overall. HCl lost a hydrogen to become Cl, so that means this is going to be our conjugate base now. NH3 has gained a hydrogen to form this, so that means this is going to be our conjugate acid now. So let's go ahead and move on. Now we have E. We got to figure out which one of these is our hydrogen, which one's our acid, and which one's our base. There is no hydrogens at all in this one, so this has to be our base. There is a hydrogen in the very first one, so this has to be our acid. So that means this hydrogen HNO3 is going to be donated to our PO4 3-. So now this gained a hydrogen, so we have HPO4. We had a 3- charge, we just added a +1 charge, so this now is going to become a -2 charge. We're slowly decreasing it from that hydrogen. And then now this HNO3 just gave away a hydrogen, so what's left over is our NO3. And it had no charge, but we lost a +1 charge, so now we have a -1 charge. This PO4 accepted a hydrogen, so this is going to become our conjugate acid. And this got rid of a hydrogen to become this, so it's going to be a conjugate base. So let's move on to our last one. So we have two of these, so we have to figure out which one is going to be our proton, our acid or our base. Well, H3O1 plus cannot accept any more hydrogens. That's the further this one's going to go. So that means this has to only give away hydrogen. So this is going to be our acid. But you're like, Miss Winkle, but our next one we have hydrogen in front, so this has to be our acid. Well, there's also a charge here, so it can still accept more hydrogens. It still has a negative charge because it wants to be neutral, so it can still accept more. So in that case, it's going to be our base. Okay. So that means one of the hydrogens is going to be donated here. So we're going to be producing one less hydrogen, so we got H2O. We had a +1 charge, we got rid of it because we're donating the hydrogen, so we have no charge. And now this one just gained another hydrogen, so now we have H2CO3. We had a -1 charge, we just added a +1 charge from the hydrogen, so now we have no charge. So that means that this got rid of hydrogen to produce this, so this is going to become our conjugate base. And this accepted our hydrogen to become this is going to become our conjugate acid now. So that is how you do your acid-base reaction product and figuring out which one's an acid-base conjugate acid or conjugate base. Now, another way to figure out the conjugate acid, conjugate base is looking at pairs, okay? What I mean by pairs is, hold on one second. Is our acid has a pair with the conjugate base, and our base has a pair with our conjugate acid. So an acid's going to pair with the conjugate base because the acid becomes NH3 here because it lost one, so they're paired up. And then the water here becomes H3O1 plus because because it was base, so it gained a hydrogen to produce this. So that's why those two are pairs. So it's an easy way to figure out what your pairs are, to figure out what your conjugate acid and what your conjugate bases are. So that means for the next example, our H4 and our 4,1 minus is a pair. And our H2R and H3O1 plus is a pair, and so on and so forth, okay? And that's how you'll do that. Now, there's also acid-base reactions called neutralization reactions. And this is a reaction in which pH of the acid and base neutralizes to 1, meaning the acid and base reacts to produce water and a salt. And that pH level of 7 comes from that water. And then you have a solid salt that's being produced. Okay, so let's go ahead and figure out the products for neutralization reactions. This is going to be very similar to the double displacement reactions, where you're going to be switching the anions, okay? So what I mean by that is that the chlorine here is going to bond with the Na, where the OH is going to bond with the H2. Now remember, for all neutralization reactions, you're going to have water plus a salt. So all of these, because the OH is going to bond with H, that becomes one oxygen, 2 hydrogen, which is water. So that is your first product. But now we have Na and Cl bonding together, and that's where we're going to have to do the charges and crisscross them. So Na has a 1 plus charge from the periodic table, and then Cl have a 1 minus charge from the periodic table. Remember, we want our metal to go first, since Na is our metal that goes first. We cross the plus and the minus, this charges out, and we'll crisscross our numbers, so we're going to get NaCl. So the two products for this one is going to be H2O and NaCl. Same thing here, okay? The ClO4, this is a polyatomic ion. Remember, make sure if you want to box your polyatomic ions, box them. So this is a polyatomic ion. And the OH is also polyatomic, so make sure you box them. Right, the OH here. OH here is also polyatomic ion, so make sure you box them so you know. The ClO4 is going to bond with our Li, and our OH is going to bond with H to produce water, so it's going to be our first product we already know. So now we got to go ahead and figure out the compound that ClO4 bonds with Li. Remember, we're going to have the metal to be first, which is Li. So Li has a charge of 1 plus from the periodic table. And we got to look at the polyatomic ion list for ClO4. Let's see if we can find ClO4. ClO4 has a minus charge, means it has a -1 charge. So that means we cross the plus and minus charges out, crisscross the numbers, so we get LiClO4 as the other product. And that is how you'll find the product for neutralization reactions. And that's it, guys. Thanks.